So in your AS syllabus, right, even your A2 syllabus, there are certain experiments that they want you to know how to set up. That means in your paper 2, they ask you to draw how you want to set up the apparatus, and then how you want to conduct the experiment, how you want to obtain the readings, and finally to analyze the results lah. So one of the things that you're going to learn today, which is compulsory, is how to determine acceleration of freefall. Now, what is the value of acceleration of freefall? 9.81, right now. Now, there's a very simple experiment you might have done in your lab, but it is very inaccurate. So the most common method to determine acceleration of freefall is you drop, let's say, a plasticine ball, right, over a certain distance. Then you find the time taken for the plasticine to fall. And then you will use the equation s equals to ut plus half at squared. And you say, okay, I know my height that it fell, my initial speed is 0, and I find the time taken for it to fall, and then I will get my acceleration of free fall. Correct? But it's very inaccurate. You know why? Because the time taken for the object to fall, let's say 2 meters, is also less than 1 second. So it's a very, very short time, and your uncertainty, if you factor in human reaction time, is about 0.1 seconds or more. So it means the uncertainty, percentage of certainty is definitely more than 10%. Understand? So it's not a good way of determining acceleration of free fall. In physics, every time you're asked to determine a constant, the best way is to plot a graph. You understand? I'll show you why it's good to plot a graph now. So what graph will I plot? Now this is another common graph you will see in your question. Now from the equation s equals to ut plus half at squared, if my initial speed is 0, then I will get s equals to half at squared, right now. Now, if I plot a graph of s versus t squared, I will get a straight line through the origin. Because if I compare with the equation for a straight line, y equals to mx plus c, my s is my y-axis, t squared is my, the other way around. T squared is my x-axis. So what does my gradient give me? Half a. And what does my y-intercept give me? 0, because there's nothing behind here. You understand? So you get a straight line through the origin. Now, which means to say, after I plot a graph of s versus t squared, which is what they did here, so you will notice that this is a graph of s versus t squared. So you can, after plotting the graph, you can draw the line already, then you find the gradient. Now the gradient of the graph will be equals to what? The gradient of the graph will be equals to half a. So it means your acceleration of free fall is 2 times the gradient of the graph. Do you understand that? 2 times the gradient of the graph. Okay? Now, you will see this type of question very common in your paper 2 or paper 1 as well. They plot s versus t squared. So next time if they show you the graph of s versus t squared, you can find the acceleration, but it's not equals to gradient, it's equals to half a. Understand? Now there is once in a while they will show you another graph which is just a modification. That means what I do is, after I get s equals to half at squared, I will square root both sides. So I'll get square root s equals to square root a over 2 then times t. Because you square root t squared, get t. Correct not? So sometimes they will plot a graph of square root s versus t, also from the same equation. But if you plot a graph of square root s versus t, then what does the gradient give you? Square root a over 2. Understand now? So be aware that they will plot graphs of s versus t squared, or square root s versus t. Because some people say, oh, I know st graph, but why do they plot s versus t squared? Now you know why. Because st graph is common, but s versus t squared is also common because it comes from the kinematics equation. Do you understand that? Okay? Now, having said all this, what I'm going to do is now I'm going to show you how to get the values of s and t squared, because if you want to plot a graph of s versus t squared, that means you need multiple values of s and t squared, right now? So you need to be able to determine them accurately. So we use a stroboscope and camera method. So how do we use a stroboscope and camera method? If you look at this setup here, you will have a ruler, and then you will drop the ball next to the ruler. And as the ball falls, you're going to capture the image of the falling ball. But how do you capture the image of the falling ball and get an image like this? You must leave your camera with the shutter open. And then you will have a flash stroboscope. And you must perform this experiment in a dark room. So which means to say, if you don't turn on the stroboscope, which is a flash stroboscope means it flashes at regular intervals. That means, for example, if you set the frequency to 20 hertz, then it will flash every 1/20 seconds, which is 0.05 seconds. That's what it means. Yeah. So let's say you have a time of 0.05 seconds between the flashes. So what will happen is this. Okay. First time, you drop the ball. Remember, it's complete darkness, right? So when the flash stroboscope turns on, it will illuminate the whole room, or in this case, this apparatus. And then your camera, which has the shutter open, will capture the image. Because as the light shines onto here, the light will reflect and come back into your camera. So you'll get the image, the first image, which is here, the top one. Then what will happen is, the flash stroboscope will turn off, so the ball will fall. And when it turns back on, then you capture the image again. But you must remember, you are keeping your camera shutter open. That means all the images that you capture are going to be overlapping on the same film. So that means on the same film, you will capture the image of it dropping. So it means every 0.05 seconds, you will see the image of the ball appearing. Where is it after 0.05 seconds? So the intervals are all 0.05 seconds. Understand? So when you want to plot the graph, you just have to use this photo. You develop the photo, and you have the ruler next to it, so you can actually see the distance it falls, right? Now, if you don't have the ruler, it's useless. You cannot develop the photo, only find the distance. Understand? Because they already shrunk in your photograph compared to real life. So you have to put a ruler next to it. So you go back to your photograph and then you plot the graph. So t is 0, s is 0. That's the first point. Second photograph here, t is 0.05 seconds. Then you measure the displacement. So 0.05 squared, what is the s? Third image is here, 0.1 seconds. So 0.1 seconds squared, because it's t squared, what is the distance? Measure this distance. So continue to do that. Then you will get many points here. Then you draw a line of best fit. Find the gradient, and it equals to half a. Then you get an acceleration of free fall. So acceleration of free fall will be 2 times the gradient of the graph. Now why I say plotting a graph to find acceleration of free fall is much better. Now number one, if there are any random errors, it will be seen on your graph as scattered. So when you draw a line of best fit, you are averaging it. So that means you are reducing a random error. Understand? And the best thing about this graph as well is that if you have systematic error, it will not affect you. Let's say there's a systematic error that causes the graph to shift upwards or downwards. But you will not affect your reading because you're only finding the gradient. You're not finding the y-intercept. That's why using graph to determine constants will be the most accurate way, rather than just taking a single value. Okay, so at least you understand how to determine acceleration of free fall and how to interpret this photograph if they give to you. Understand? Now the next thing we want to talk about is terminal velocity or terminal speed, maximum speed. So terminal velocity or terminal speed, right, only occurs when you have drag force. What is drag force? Drag force is due to the fluid opposing your motion. Example, like when you are running 100 meters, you feel the wind in your face, right? And it actually slows you down. So that is your air resistance, which is a drag force. In water, if you are swimming, right, the faster you swim, the harder you feel that you can move, because that is your drag force as well. So air resistance is also a type of drag force, but it's a special name given if you're in air. But you want to use drag force in air, in liquid, also can. But you cannot use air resistance in water, even though air is air, right, in Malay, but it's not the same. Correct? So it is drag force generally. So drag force increases with speed. So let me explain to you what happens. So imagine if you drop an object from a helicopter, right? From rest, you know the speed will increase. But will the speed increase forever? No, it will reach a maximum speed. Another application of this was one episode of this show, TV show called Numbers. There was this university student found dead at the bottom of a tall building, suspected of committed suicide. But to rule out homicide, that means people murdering him, they have to investigate further, but they want to find out from which floor he fell, because they only saw his body at the down. So what they did was, they looked at his injuries and determined that he was falling at terminal velocity, because there's a higher speed, so his bones, or the way they break, and now that's when you know how fast he was falling. Because if you don't fall very high, you only break your leg, probably not your other parts. But his injury was so extensive, that means he was falling at terminal velocity. So how high must a man jump from a building to reach terminal velocity? It's about 100 meters. So after that, anything more than 100 meters, you will still reach the ground at the same speed. That's why they figured out that 100 meters and above, he must be from one of the floors. So they could eliminate all the floors that are 100 meters and below. So then they only left with few more floors left, so they don't have to investigate the whole building. Do you see that? So terminal velocity always exists, especially if there is drag force. Understand that? So initially when you fall, I show you the equation. Initially when you are falling, let's say you drop from rest, like this, your speed is 0 right now. You fall from rest. What will be the force acting on you? You will only have your weight and upthrust. Now, upthrust is not the same as drag force. Again, another common mistake. Drag force is when you move, then you get drag force, and it will increase with speed. Why is there drag force? It's because you have to displace the fluid as you are moving. That means if the ball is falling through the air, it's to push the air away. As the ball is moving through the water, it's to push the water away. So that's the origin of drag force. But upthrust is due to difference in pressure of the fluid, which exists whether or not you're moving. For example, when you're in a swimming pool, you're just standing or just lying on your back, you can still float right now, because there's upthrust. You don't have to move, you still have upthrust. So upthrust is there, but upthrust in air is negligible. Now, why is upthrust in air negligible? Because in air, right, the upthrust, remember Archimedes' principle? Archimedes said that the magnitude of the upthrust is equivalent to the weight of fluid displaced. So that means when we are in air, right, we have an upthrust due to the air, but the magnitude of the upthrust is equivalent to the weight of the air displaced by our body. And air is heavy or light. So that's why the air displaced by our body has negligible weight. That's why our upthrust in air is negligible. So always remember this, anything that falls in air, you can always ignore upthrust. You will notice this in all your questions as well. Anything that falls in air, you can ignore upthrust. But in water or oil, you cannot ignore upthrust. You know why? Because imagine you're in water, the weight of the water displaced by your body, and I weigh it, isn't it heavy or light? Is it heavy or light? Heavy right now. So anything that moves in liquid, you must consider upthrust. Anything that moves in gas or air, you can ignore upthrust. You understand now? Okay? So for this case, I'm doing general. Weight and upthrust there. But in air, you can ignore upthrust. But this is general. So what is your net force acting now? Weight minus your upthrust right now. Agree now, guys? Wait, let me just write nicely. Okay, now, so this becomes your net force, which is equals to MA. Now, if your weight is bigger than upthrust, you will fall. But if your weight equals to upthrust, you will float. No? But when we drop an object in air, the upthrust is negligible, so therefore the weight will be much bigger, so you'll fall right now. So when it falls, what will happen is this object will now gain a certain speed v. But when it has a speed v, that means what are the forces acting? it will have your weight as usual. You also have your upthrust as usual. But you have another extra force, which is your drag force. Initially, no drag force. Why? Your speed is 0. So when speed is 0, no drag force here. But the moment you start to move, you have a drag force. Do you understand that? Now, what is the formula for drag force? You don't have to know, they will tell you, but it increases your speed. So now, your equation will become what? Your equation will become your net force equals to your weight minus the upthrust minus the drag force. Okay, I just put drag force here. Equals to MA. So far so good? Now, your weight will never change. So let's give it a value. Let's say I give it 10 newtons. Your upthrust also won't change. So let's give it 2 newtons. But what will change is your drag force. Now let's say you're moving very slowly. Let's say your drag force is only 3 newtons. Can you see I will have a net force of 5 newtons? So when you have a net force, you will have an acceleration and you will start to travel faster, right? When you travel faster, the weight won't change, upthrust won't change, but your drag force will change. So it will go higher and higher. Finally, when it reaches to 8, then what happens to your net force? 0. And when you reach 0, that means your acceleration is 0. So what is your velocity? Constant. So that is what we mean by constant velocity or maximum velocity, called terminal velocity. Do you understand that? Okay? Now, if you look at the two graphs which they will like to ask you, one is the graph of velocity versus time, one is acceleration versus time. Imagine the acceleration versus time first. So you start off with maximum acceleration, but then as your net force decreases, because your drag force increases, your drag force increases, your net force will decrease. Your acceleration will drop slowly to 0. So this is a graph of A versus T. Understand that? If there's no air resistance, it will be a straight line, like this. But because there's air resistance, it will drop like this. Or drag force, it will drop like this. What about velocity time graph? Remember the value of AT graph gives you the gradient of VT graph? So the value here is less and less positive, all these values. So the gradient of this graph must also be less and less positive. So it must be pointing up and getting less steep. Finally, it reaches 0 gradient. Why? Because your value drops to 0. So these two graphs you must remember. This is for terminal velocity.